Myself, Dr.P.Vijayakumar, Associate Professor, Department of Electronics and Communication Engineering, Aditya University. In today's session, we are going to see the operations on random variable. We will see the fundamental operation, expectation. So we will see the definition of expectation for continuous random variable and discrete random variable. And finally, we will see the problems related to the expectation. So we will be learning two learning outcomes. One learning outcome is we will see the definition of expectation for both continuous random variable and discrete random variable. The second learning outcome is we will apply the expectation concept for solving the real-time examples. So coming to the operations on random variable, we will have different operations like expectation, moments, variance, like that. So many operations are there for a single random variable. The fundamental operation we perform on random variable is expectation. Expectation is also otherwise known as the mean value or the average value. So the mean or average value of the probability distribution function of a random variable x or statistical average of a random variable x is generally denoted as x bar, e of x, mu x. So we can denote with any of these three symbols. If it is a continuous random variable category, the expectation of x can be computed as integration minus infinity to infinity x into fx of x dx. If it is a discrete version of random variable, so we need to use this formula, summation of I xi into p of xi. Here we use probabilities. Here the density function is required for computing the expectation of a continuous random variable. So first we will see one problem related to the expectation. So when a fair dice is thrown, we need to compute the average value. When a fair dice is thrown, the sample space is 1, 2, 3, 4, 5, 6. So 6 outcomes are possible totally. Firstly, what we need to do is we need to build the table, the possible number of outcomes for the random variable, and we need to assign the probabilities for the values of random variable. The probability of getting 1 when a dice is thrown is 1 by 6. All are equiprobable. The probability of getting 2, 3, 4, 5, 6, everything is 1 by 6. All are equiprobable, equally likely events. 6 possible outcomes, 6 are equally likely. The sample space is 6 and the favorable outcome is 1, 1 by 6, 1 by 6, so on, all 1 by 6. Now we need to compute the expectation. Since the random variable belongs to the category of discrete random variable, so for a discrete random variable, the expectation formula is summation I is equal to 1 to 6 xi into p of xi. So xi means the value of random variable. When it is 1, the probability is 1 by 6. When it is 2, the probability of 1 by 6. When the dice number is 3, 1 by 6. It goes on up to when dice value is 6, its probability is 1 by 6. So when you calculate all the values and add them, you will get the expectation as 3.5. In general, the expectation can be either positive or negative. Okay, it depends on the data. So there is possible chance for getting a negative and positive value. Sometimes it can be equal to 0 also, average value. So let us see one example for continuous random variable. A continuous random variable is given to us. So for a continuous random variable, the expectation formula, what we need is, we need the density function for computing the expectation for a continuous random variable. The density function is given in the problem. Fx of x is equal to 2x over the limit 0 to 1. So now we need to compute the expectation 0 to 1, x into fx of x is 2x dx. So it is equal to 0 to 1, 2x square dx. So the integration of x square is x cube by 3, already 2 is there, limits are from 0 to 1. We will get 2 by 3. So this is how we can apply the expectation formula for a continuous random variable. In the previous example, we have seen the problem related to discrete random variable. Now we will see the expectation of a function. So expectation of a function means what we need to do is we need to replace, instead of x, the function will be kept. G of x, fx of x, dx. Okay. So the same formula is applied for the functions. Here the function given as x cube by 2 and the density function is given as 1 by 4 over the limits 2 to 6. So the limits are from 2 to 6. The function is x cube by 2 and the function value is 1 by 4. So it will be x cube by 8, 2 to 6 dx. Now when do the integration, x cube will be x power 4 by 4, already 8 is there, limits are from 2 to 6. Substituting we will get 40. So first problem we have seen the problem related to the discrete random variable, second one related to continuous random variable, and the third one is related to the function, expectation of a function of a random variable. Also there are few properties related to the expectation. Expectation of Ax is A into E of x. Similarly, expectation of Ax plus B is equal to A into E of x plus B. So we use these properties whenever there is a need to apply these properties. We will apply these concepts. Expectation of Ax plus B is equal to A into E of x plus B. So here one practical example is given. The nickel contained in an alloy, says the random variable, given the density function. It is described in the form of a density function, continuous random variable, fx of x is equal to x square by 10 over the limit 0 to 5. Now they are asking calculate the mean value or expectation value. So we know that the density function is given, the expectation formula is minus infinity to infinity x into fx of x dx. So applying the limit 0 to 5, x into x square by 10 dx, doing the integration we will get 25 by 16. The mean value we will get 25 by 16. The mean value is nothing but the expectation. This is one more practical problem which is also related to the uniform distribution function. So we know uniform distribution function is defined as fx of x is equal to 1 by b minus a less than x less than b. Here given a random variable v which is uniformly distributed over the limits 0 to 5. So the uniform density function will be 1 by 5. Given the pressure P on the surface on airplane is given by the relationship P is equal to 0.025 V square. Find the expected value of the P. So the function is given to us. This problem comes under the category of expectation of a function of a random variable. Function is given like this, and density function they mentioned it is a uniform density function. We mathematically applied the values and we developed the uniform density function. So expectation of P will be P into Fv of V dV. Since the function P is also in terms of V square, so V square integration is V cube by 3. Substituting the limits we will get 0.0208. That is 2% chance is there for the given data. So already mentioned that we will apply the properties of the expectation. So the properties which we need to remember for the problems is particularly this property, expectation of Ax plus B is equal to A into E of x plus B. So that means expectation of constant is constant, expectation of constant into x is constant into expectation of x. So we will apply this formula for calculating the problems. So here a continuous density function is given 5 into e power minus 5x. So this problem is related to the exponential density function. It is similar to exponential density function, lambda into e power minus lambda x, where x is greater than or equal to 0. It looks like a function which is pretty much close to exponential density function. Now they are asking us to calculate the mean value. We know that for a exponential density function the mean value is 1 by lambda. So this is our guess. If this is an exponential density function, the mean value should be 1 by lambda. Let us check whether we will get the same value or not. So we are taking the 5 into e power minus 5x. So for a continuous random variable this is the formula. Now 5 I am taking outside, x into e power minus 5x. We are applying the rule integral u dv, uv minus integral v du. Here u is x, dv is e power minus 5x, v will be e power minus 5x by 5. So applying the uv rule and solving, what we got, 1 by 5. So lambda, if you compare here, lambda is 5, the mean value is 1 by lambda, 1 by 5. Clearly this density function is nothing but exponential density function. So our guess is correct. The exponential density function mean is 1 by lambda, so it is 1 by 5. Next, expectation of x minus 1 whole square. So in order to compute expectation of x minus 1 whole square, first what we need to do is, we need to expand this expression, expectation of x square minus 2x plus 1. And we will apply the properties of expectation. Expectation of x square minus 2 into expectation of x, expectation of constant is constant. So to compute this one, first what we need to do, we need to calculate expectation of x square. Expectation of x square is also called as mean square value. So we are computing the mean for the square value, e of x square. So e of x square is something expectation of a function. So replacing the function x square, fx of x dx, again here I am applying the uv rule, integral u dv is equal to uv minus integral v du. I am applying this rule and calculating, what we will get is 2 by 25, expectation of x square, and expectation of x is 1 by 5. So the answer will be 2 by 25 minus 2 into 1 by 5 plus 1. Taking the LCM 25, 2 minus 10 plus 25, 27, 17 by 25. So the answer will be 17 by 25. We applied the property of expectation here for computing expectation of x minus 1 whole square. And one more problem, expectation of ax plus b is a into expectation of x plus b. So applying that property, expectation of 3x minus 1 can be rewritten as 3 into expectation of x minus 1. What we will get? 3 into 1 by 5 minus 1. So minus 5 plus 3 by 5. What we will get? Minus 2 by 5. Okay. So we need to remember, or we need to recall the properties of expectation, which we have discussed in the previous sessions. And one more problem we will see by applying the properties of expectation for a discrete random variable. A discrete random variable data is given to us. A discrete random variable takes values ranging from minus 2 to plus 2, minus 2, minus 1, 0, 1, 2. And given, mentioned the probabilities of these random variables, 1 by 5, 2 by 5, so on, 1 by 5. Now we will apply, first what we will do is, for the first problem, it is pretty much direct. They are asking us to compute the expectation of x. For the second problem, we will apply the property of expectation. Third one is the expectation of a function of a random variable, mean square value. And fourth property, we will apply the properties of expectation. So second and third, we apply the properties. First one is direct, third one is also direct, which is related to expectation of a function of a random variable. For a discrete random variable, the mathematical formula is summation I is equal to minus 2 to 2 xi into p of xi. So substituting these values, minus 2 into 1 by 5, minus 1 into 2 by 5, 0 into 1 by 10, 1 into 1 by 10, 2 into 1 by 5, we will get the mathematical expectation is minus 0.3. Next, expectation of 2x plus 3. Now we will apply the property of expectation. This can be written as 2 into e of x plus 3. E of x we got minus 0.3, 2 into minus 0.3, minus 0.6 plus 3. We will get 2.4. Next, mean square value, expectation of x square. So expectation of a function of a random variable, simply minus 2 whole square into 1 by 5, minus 1 whole square into 2 by 5, 0 square into 1 by 10, 1 square into 1 by 10, 2 square into 1 by 5. Doing this, we will get 21 by 10. So that is 2.5. So this is the mean square value. Now we will apply the properties of expectation. First, we need to expand this expression. 2x plus 1 whole square can be written as 4x square, 4x plus 1. Now we will apply expectation. 4 into expectation of x square, 4 into expectation of x, expectation of constant is constant. Applying that, we will get 8.2. Expectation of 2x plus 1 whole square, we will get 8.2. Next, we will see one more problem related to the dice. Here, two unbiased dice are taken. When two unbiased dice are thrown simultaneously, the total sample space is 6 into 6, 6 square. That means 36 different combinations are possible. Next, we are asked to compute the expected value of sum of the numbers on the dice. So when 2 dice are thrown, some of the numbers possibility are 1 plus 1. The minimum possibility is 1 plus 1. The maximum possibility is 6 plus 6. So 2 to 12, any number can come. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the corresponding probabilities first we need to compute. So like this we need to compute. Once you know the probabilities, once you know the random variable values, you can apply the formula directly. Expectation of x is equal to summation I xi p of xi. So we need to tabulate a table something like this. So for getting sum 2, only one chance is there, 1 by 36. For getting sum 3, 2 chances are there, 2 by 36. Again for getting sum 7, 6 chances are there. For example, for this we will see 3 plus 4, 4 plus 3, 2 plus 5, 5 plus 2, 6 plus 1, 1 plus 6. Like this, 6 chances are there. So this is the maximum possible chances for getting the sum 7 on 2 dice, when 2 dice are thrown. So like this, we need to compute all the probabilities for the assigned random variable values. Later on, we need to apply the formula. So doing the mathematical work, doing the calculation, the expected value of sum of random variables, sum of 2 values is 7. So on an average, we will get the sum 7. But the sum ranges from 2 to 12, but on an average we get 7. Here a graph is given to us. This is nothing but the density function. Now we are asked to compute the mean value of the random variable. So we know the formula y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. So using this formula, these limits are 0, 0. Here the limits are 2, 1 by 2. Here the limits are 4, 0. So up to this part is one expression, up to this part is another expression. Up to this part it is 1 by 4 x. And from 2 comma 1 by 2 to 4 comma 0, the expression is 1 minus x by 4. So the density function is computed, the density function is x by 4, 1 minus x by 4. When the limits are from 0 to 2, this is the case. When the limits are from 2 to 4, this is the case. So the expectation formula for a continuous random variable is minus infinity to plus infinity x into fx of x dx. Doing this calculation, we will get the expectation as 2. What we have done in this session is, firstly what we have done, we defined what is meant by expectation. We defined expectation for a continuous random variable as well as for a discrete random variable, and we solved problems related to continuous and discrete direct problems, and also we solved expectation of a function of a random variable, and also we used the concept of the properties of expectation, particularly this property, expectation of ax plus b is equal to a into u of x plus b. Expectation of constant is constant, expectation of ax is a into u of x. So we have seen the definitions and we solved some real life problems which are related to the expectation calculation. So in the next session what we will do is we will solve the problems and we will see the concept of variance. So what is meant by variance? Expectation gives you the central value of the statistical data. Any data is given, the central value is computed using expectation. Central tendency of the data is given by expectation. So in the next session we will see the variance, which gives you the measure of spread or measure of dispersion of the data from the central value, and also we will cover so many different problems related to the variance. Thank you.